Everyone, are you able to listen? Can you hear the voice? Is it clear? Okay, good. So now we'll start with the lecture. Good morning. We are starting with the most interesting subject of all, that is community dentistry. I'm sure you're all excited about this subject. So we are going to go through almost all the important MCQs that you all have had in the test. If you all have any doubts, please feel free to ask during the lecture itself. There are some people who have mailed me a few doubts that I'll clarify at the end of the lecture, especially in statistics. So if you all have any doubts in statistics also, you can stop me at any time and I can repeat my explanation. So feel free to ask doubts. And after every 50 MCQs, we'll be taking like a short 15-minute break. And if you all get hungry in the middle and want to go for lunch also, you all can ask and we can stop the lecture and we can take like a half an hour, 45-minute break. So let's begin. Can everyone hear properly? Is it fine? Voice clarity and PPT? Okay. So we'll begin with our first MCQ, which has to do with toothpaste or dentrifices. Now it's a very straightforward question. You should know the composition of dentrifices thoroughly. That which of the following components acts as a buffer in your dentrifice? Now the first answer itself is the right answer, that is hydrated sodium. You all know that hydrated sodium acts as a buffer. Xanthan gum acts as a binder to bind all the components together. Sodium lauryl sulfate is nothing but a soap or a saponifying agent that will reduce the surface tension of your debris or any stuck food particle and lubricate it so that it gets cleaned easier by your toothbrush. And then the last option is sorbitol. Sorbitol here they have said it's a humectant, but sorbitol is also a sweetening agent, so it has a dual purpose, that humectant as well as an artificial sweetener. The third MCQ also relates to dentrifices, so I've combined the two. That is, what is the role of this Carrageenan carbomer 940? So like you have the xanthan gum, that is also a binder in your toothpaste. Now this is the composition of a dentrifice that is given to you in your explanations. Stick to this composition. Most of your questions will come from here itself. Now there are few things that are not given here and I wanted to discuss with you all is that you all know what is, like we have nowadays, there's advertising also of toothpaste used for sensitivity, that is desensitizing toothpaste. Are you all aware of what is the component in a desensitizing toothpaste? For example, you have ads of Sensodyne. Very common, those UK dentists are marketing Sensodyne toothpaste. So what is the desensitizing agent in Sensodyne toothpaste? Are you all aware? Can somebody give me the answer? Very good. It is potassium nitrate. What about Colgate sensitive? Is it same potassium nitrate or is it something different? Colgate sensitive generally sticks to potassium citrate, but strontium chloride can also be one of the components. And now lately Colgate has been advertising something called as Colgate sensitive Pro Relief. Do you all know what technology in Pro Relief are they currently advertising for desensitizing? Novamine is also one, very good answer. Novamine, that is glass. But Colgate sensitive Pro Relief, the most advertised currently. Any idea? Okay, Colgate sensitive Pro Relief currently is using something called as Carrageenan technology. Like you all know, arginine is an amino acid and it is freely available and it binds with the tooth structure and it aids in desensitization. So you all are supposed to be aware of what is there in desensitizing toothpaste also. Along with that, currently there is one ingredient in Colgate Total that has come under the scanner because it is said to cause cancer. It is lately in the news in the past 2-3 days. Do you know which ingredient in Colgate Total? It has come under criticism and it's come under a lot of public scan because it can cause cancer. What makes Colgate Total so total? It is also there in Pepsodent. but Pepsodent doesn't market it that much as Colgate does. One ingredient in Colgate Total that has come under the scanner in the last week. If you read any news related to dentistry, you will see that this component is there. It's making news. Okay, I'm not getting any answers. The answer is triclosan. Have you all heard of triclosan? Okay, triclosan, everybody's heard. So triclosan is used in Colgate Total and it's used in Pepsodent also. And they market it as an anti-plaque agent. But if you go through the news, probably even on Yahoo News, it is still playing that in the past 2-3 days, it has come under the scanner, and the FDA, that is Food and Drug Administration, they have also been criticized that triclosan is now proven to cause cancer in rats and some bone defects and hormonal changes. And now people have been withdrawing the triclosan component from hand washes and soaps, etc. So now it has come under question that should this ingredient still be continued in toothpaste? Though Colgate and Pepsodent are saying currently no, that it's safe, but still it is a questionable component today. Is that fine? Can we move ahead? Any doubts? First two MCQs. Okay, now we come to fluoride, the heart and core of preventive dentistry. So now this question is very straightforward, objective question, that is how much fluoride is released by topical fluoride system. The answer is 0.5 to 3.5 mg. See, whenever you are using topical fluoride systems, especially self-applied topical fluoride system, which is the most commonly self-applied topical fluoride system that we are using? Most common self-applied topical fluoride. Okay, self-applied topical fluoride, either APF is professionally applied and sodium fluoride is also professionally applied. Self-applied, that you use every morning, I use every morning, it is nothing but your toothpaste. If you read the ingredients of your toothpaste, or like we had in the previous slide also, our toothpaste are having, we'll just go back, sodium fluoride or sodium monofluoride. These are the two most commonly used self-applied topical fluorides. Now, whenever we say self-applied, we have to be careful of ingestion of fluoride. So, generally, in case of any topical fluoride use, there is a chance of ingestion. You might swallow, especially in the case of children. So, we limit the fluoride delivery to somewhere between 0.5 to 3.4 milligrams of fluoride. Is that clear? Okay, how much is the concentration of fluoride in a toothpaste in ppm? How much fluoride does your toothpaste have in ppm? Either sodium monofluoride or sodium fluoride. You can get your toothpaste and read on it also, no issues. 1000 ppm. Good, that is the right answer. It can be somewhere between 900 to 1000 ppm. So 900 to 1000 ppm generally delivers 1 mg of fluoride per gram. Okay? Fine. Now again the next question relates to fluoride itself. That amongst these fluoride delivery systems, in which method do you see maximum reduction of dental caries? The answer is very simple. It is community water fluoridation. See, whenever you are having self-applied topical fluorides, you should always take precaution that the amount of fluoride that you are giving to a person is less than what will be in a professionally applied, because it is not a supervised use. Okay, in professionally applied, you have the dentist, the dental assistant who are there and they are supervising you and they can control the amount of fluoride delivery. But when you go for self-applied topical fluorides like toothpaste or mouth rinses, there is nobody to continuously scrutinize or supervise their use. So generally, the amount of fluoride in self-applied topical fluoride itself is less. Hence, the amount of reduction will be less, that is 20 to 30%. And in community water fluoridation, it is high, that is 50 to 65%. When you have dietary fluoride supplements, they will also give an equal amount of fluoride reduction, that is 50 to 65%. Whenever community water fluoridation or your dietary fluoride supplements are not available or they are not used in the community, the most helpful form that is commonly used is your self-applied topical fluoride, and that is in the form of your dentrifices. Is that clear? You are able to hear? Somebody is asking the answer. The answer for ppm of fluoride in toothpaste is somewhere around 1000. Okay. Now this is a very simple physiology question, that what is the normal amount of saliva? It is 1 to 1.5 liters per day. Can somebody tell me what is the normal urine output? We are moving to physiology. What is the normal urine output of an individual? Nobody wants to answer physiology? Nobody? Fine, I'm not going to give you the answer. You find out what is the normal urine output and I'll give you the answer only at the end of the day. Somebody's come up with 2 to 2.5 liters. We'll discuss this. Okay, so somewhere around 2 liters or 1 to 1.5. What I wanted to draw is a parallel between amount of saliva and urinary output. It is almost equivalent. However, your urine output can be a little more. Okay. Now the next question is also physiology. Unstimulated whole saliva flow is, it's a theoretical question. The answer is 0.5 ml. If you see the table that is provided in your explanations, you can add it up to somewhere between 0.4 to 0.5 ml. And when you say acid stimulated or stimulated saliva, we generally say it is 0.8 to 1 ml per minute. Now what is interesting about resting saliva and stimulated saliva is you should understand, when it comes to fluoride secretion through saliva, resting saliva has more fluoride than stimulated saliva. Okay? Even though resting saliva is 0.5 ml per minute, the amount of fluoride concentration in resting saliva is more than that in your stimulated saliva. Any doubts so far? Understood about resting and stimulated saliva? Fine. Let's move to the next question. We are still in fluoride. The fluoride concentration in saliva is about. Okay, now these are all a series of theoretical questions that you should start making tables about. Okay, the fluoride concentration in saliva is somewhere 2/3 that of the plasma level. I don't think there is much explanation required here. Somebody is asking about question 6. In question 6, the only point that I added was that the fluoride concentration in resting saliva is more than that in your stimulated saliva. Is that clear? Okay. Fine. Now again we are in the concentration of fluoride. Now this question is asking you about concentration of fluoride in sweat. See, these are type of questions which are so theoretical that you can't play much of a guessing game. So like I said before, just have a table in front of you and you start jotting down concentration in saliva, concentration in plasma, concentration in sweat. So the concentration in sweat is answer 4, that is 0.067 to 0.5 parts per million. Now I have given a short summary about fluoride concentration. So fluoride concentration in human milk is somewhere between 6 to 12 milligram per ml. In sweat, like we just saw, it is 0.067 to 0.5 ppm. In saliva, it is 2/3 that of plasma. In tea, it is 98 ppm. In dried tea leaves, it is somewhere from 100 to 400 ppm. And in dried fish, it is 100 to 20 ppm. Now, why I have given you all these values is because these are very theoretical questions. You can't look at the question and guess, okay, this might be or this might be. There's no logic. It is something you know or you don't know. And these kind of questions can sometimes be very decisive when it comes to getting correct MCQs. So you can have such kind of tables, you can prepare them for yourself. This is just the gist of what I am giving. And you can read them before you go into your exam so you don't forget all these numbers. Is that fine? Has everybody seen all these concentrations? Okay, somebody is saying go slow, fine. Yeah, 6 to 12 micrograms, right, it's a misprint. Okay, I'll just move ahead. Now now this question is asking is how much time it takes to attain maximum fluoride concentration after ingestion of soluble fluoride dose. So once you've ingested some form of fluoride, say a fluoride supplement or a lozenge, how much time will it take to have the maximum concentration in your plasma? So it is generally 30 to 60 minutes. That is the time that you achieve maximum fluoride concentration in your plasma. Fine. How much was the concentration in saliva as compared to plasma that we just discussed? Fluoride plasma level will depend upon the fluoride dose that you have ingested. Okay, correct, it was 2/3. Fine, so you all are listening. I was just checking. Okay, now we come to a very simple question. It is asking in public health dentistry, major of the emphasis is given on which of the following. What was the previous name of this subject? What was public health dentistry previously called as? It was not public health dentistry, it was something else. What is the name of that Peter textbook? PCD, that is Preventive and Community Dentistry. Very good. PSM is different. PSM is not Peter, PSM is Park. Okay, so the whole name was Preventive and Community Dentistry. So obviously, when you come to public health, like we always say, prevention is better than cure. Our major emphasis is on preventive care. So we have the answer, that is promotive and preventive care. Now we come to the favorite topic of everyone, that is statistics. Now this question is very simple, though it looks pretty big, that what are the uses of statistics in dental science? What you have to understand is why we need statistics or why we need an index. See, basically what you want to do is, in public health dentistry, you want to prevent dental diseases. Is that right? Like we were just discussing prevention. So prevention of dental diseases. So when you want to prevent a disease, you should know how much of the disease is existing in your community. So once you know how much of the disease is existing in your community, you should know why it is there. Why it is there? Are there any facilities available to the people that the disease is still there? Are there no facilities? If the facilities are there, are people using them? If people are not using them, why are people not using them? See, it can be due to money, it can be due to distance, it can be due to time. So once you have all these factors, once you know that what is the status of disease, what are the facilities, are people using them, are people not using them, why people are not using them, once you have all these answers, you can then have some, plan of action as to what you can do. Now suppose you have lung cancer and smoking. Now initially passive smoking was not into limelight, but there was one study by Hiroshima in Japan amongst housewives of husbands who smoke. They realized that housewives of husbands who smoke had a 50% more chance of lung cancer. So because of this finding, now you have ban of smoking in public places. So this is one example of how you use a statistically significant result of a study to form laws or administration. So hence all the above options are uses of statistics. Is it clear? Have you all heard about this Hiroshima study in Japan about passive smokers and their husbands, wives? I think I had covered it in the last lecture. It's a very famous study. Is everyone familiar with this study? I think everyone is logged out. Is anybody there? Okay, we'll move on. Okay, now the next question is also a little confusing. What is sampling frame? Now the correct answer here is that it is a list of all sampling units that form the target population. Now let's have a look at this diagram and we will get an overview of what is sampling frame. So now what you see here is theoretical population or your whole population. Suppose you want to do a study in India and you want to test some toothpaste. Now you have the population of India somewhere 100 billion. So can you do a study in the whole 100 billion? No, of course not. So what you have is a whole population. From the population, you are going to select some people who will represent your sample. So they will form your sample and they are called study population. So your study population comes from your whole population. Now they are selected based on the inclusion-exclusion criteria of your study. Now whoever is in the study population, you need to have a list of all those people. Now from your study population, when you have a list, it is called as a sampling frame. Every person in that list is called as a unit, a sampling unit, okay? And from this study population, you have the sampling frame and you will randomly select from the study population what you have is your sample. So are you clear? You have a theoretical population from which you will have inclusion-exclusion criteria, your study population. You will have a list of all those people, they will form the sampling frame. Every person in that frame is your sampling unit and finally you have your sample. Is this diagram clear? Okay. Now can you tell me one such survey where you include the whole population? One such survey where you have to include the whole population of the country. When will you have to include the entire population of the country? Very straightforward question. Very good. In the census. Census is conducted every how many years? How many years? After how many years do you conduct census? 10. Excellent. So which was the last census? Which was the last census that was conducted in which year? Oh my god, so many tens. 006, I think your zero number has got stuck. Census is no, last census was conducted in, see if it is conducted every 10 years, generally it is the first year of every decade. Very good. It is 2011. When was the first census of India conducted? First census of India was conducted in the year. Anybody? I'll give you this answer at the end of the lecture. In the meanwhile, you can find out. 1961? No. Much before. 2011 was the 15th Indian census. So that should be your clue. You can go back and think about it. 2015 was the 15th Indian census. Fine. And just so you know that whenever it comes to All India or all such exams, you better know the statistics of the Indian census that is currently taking place. So just have a look at the 2011 census and the important stats like literacy rate or sex ratio and which state has the highest literacy or which state has the most equal sex ratio. Fine. We'll move on to the next one. That is now from sampling frame, we have come down to sampling methodologies and surveys. So now if you read the question, the economic survey sampling methodology, which is done when there is a need to sample a specified proportion of the population in order to estimate disease prevalence accurately, is known as. See, generally when you go for a survey, you go in one point of time, so you generally look at the prevalence of the disease. Do you all know the difference between prevalence and incidence? What is prevalence and what is incidence? Okay, you all know. So prevalence is nothing but the old plus new cases, and incidence is the new cases. So now this economic survey sampling methodology is called as Pathfinder survey. Now we'll see what are the characteristics of a Pathfinder survey. Now Pathfinder survey, it uses the stratified cluster sampling. Now I'll be discussing sampling in the next slides, in the next few questions, so you'll get an understanding better. Just keep it for now that it uses stratified cluster sampling. This itself is an MCQ. Which sampling methodology is used in the Pathfinder survey? So it is stratified cluster. Now it uses the most important subgroups. It uses the differing levels of disease, and there are some specified age groups given by WHO. Now what it means is that suppose you want to find out the level of periodontal disease in an Indian population. Now like we just saw in that sampling frame diagram, that you cannot take the whole population of India. You have to take a particular sample. But now periodontitis includes gingivitis also. So you cannot just stick to one adult population from lower socioeconomic status and say yes, that the periodontitis is very high in India, people are not maintaining hygiene. So that will create something of a discrepancy, or what you call as a bias. So when you are conducting a survey, it is essential that if you want to talk about one disease, say periodontal disease, you should take all the people who can have varying levels of the disease. So that is what the third point means, is differing levels. Gingivitis, then you go to pocket, loss of attachment, bone loss. So all these levels should be covered. So gingivitis generally you will have in your pubescent group. Severe forms of periodontitis maybe after the middle age group. So all these age groups need to be incorporated. Now WHO. What do you mean by WHO? What is the full form of WHO? Yeah, I'll just repeat. Somebody wants me to repeat. But in the meanwhile, can somebody give me the full form of WHO? Nobody? World Health Organization. Very good. Where is the headquarters of WHO? Headquarters of WHO? Very good. Everybody knows. Where is the headquarters of WHO? Geneva. Excellent. Geneva is there in which country? New York is the wrong answer. WHO is situated in Geneva. The headquarters of WHO is in Geneva. Where is Geneva? Which country? Geneva belongs to which country? No, not USA. Okay, the headquarters of WHO is in Geneva, Switzerland, and somebody has written Delhi. See, WHO has 6 regions under it, so the headquarters of Southeast Asian region of WHO is Delhi, but the headquarters of World Health Organization is in Geneva, Switzerland. Very good. Now a lot of people are answering correctly. Okay. Fine. So now this WHO has given these 5 groups which will have almost all the diseases in varying amounts. That is, at the age of 5 years, you have all your primary teeth. At the age of 12 years, except for the third molars, generally you have all your permanent teeth. At the age of 15 years, all your permanent teeth have been in the oral cavity for at least 3 years. So you can study the effects of the environmental factors on all permanent teeth more accurately at the age of 15. By the time you are 35 to 44, you see a lot of periodontal disease. And by the time 65 to 74, there can be teeth loss, a lot of RPDs, dentures. So 65 to 74 years might tell you the past treatment that the patient might have sought. And if you see a lot of people who are edentulous at the age of 65 to 74, you can either conclude that they were unaware of dental treatment, or they did not seek dental treatment, it was very expensive, or they were just not interested in seeking oral health care. Is that fine? Any doubts so far? Please remember these 5 WHO age groups. They are also very important, a very common MCQ. Is it clear? The 5 WHO age groups. Okay. So we are moving ahead. Data presentation done in terms of magnitude is known as. Now when it comes to magnitude, you mean a number, a numerical quantity, like say weight, 50 kg, 60 kg, 70 kg. So whenever you have a magnitude or a number that is quantifiable, we say it is quantitative data presentation. Chronological, like you already know, history, chronology of events that is based on time. Qualitative is generally when you cannot represent something in numbers like race, sex, color of eyes. Quantitative, like we just saw the MCQ, it's magnitude, and geographically is area-wise. Very simple question. Any doubts so far? No, right? Fine. Now, this is an interesting question, that is the coverage of geographical area through dental clinics can be depicted by the following. Now amongst all the data representation diagrams, the one that uses geographical area for depiction is cartogram. Are you aware of one famous cartogram in epidemiology? Somebody saying no. 8006, no is for what? Okay, there is this very famous cartogram. I'm sure you all have heard of John Snow. John Snow was the one who finally ended the epidemic of cholera in England. So if you see this diagram, in England in 1854 there was a huge epidemic of cholera and they were unable to trace why cholera is affecting so many people at once in England. So what this Mr. John Snow did was, he took the map of London and he plotted in red dots where all most of the cholera cases were occurring. So when he plotted this dot, he came to realize that there is a pump in the Golden Square district around which most of the cholera cases are occurring. That is, wherever this pump is supplying water, most of the people in those areas only are getting cholera. So he went and he himself sealed the pump so that water was no longer available from that pump, and slowly the cases of cholera started declining. So he is the one who used cartograms to stop the cholera epidemic. Now John Snow is known as the father of epidemiology. I'm sure you know that. Do you know who is the father of biostatistics? Okay, video is hanging. Just a second. Is the video fine now? Have you all gone to the correct slide? Very good. John Grant is the father of biostatistics. So please don't get confused. John Snow is the father of epidemiology and John Grant is the father of statistics. Fine. Moving to the next one. That following are the properties of measure of central tendency used in dental sciences. Now please tell me the 3 common central tendency measures that you all are aware of. 3 common central tendency measures that you all are aware of. Mean, median, mode. Excellent. See, like the word suggests, central tendency. Now please don't get confused at what are these fancy statistical words. They are very simple if you break them down. Central tendency. Tendency, that is whatever you have, suppose a series of 100 observations. Let's say weight of children in a school in standard 8th division A. Now generally age and weight are supposed to correlate. Now we will not take into consideration, there will be some fat children, there will be some thin children. So whenever you take a population, you will get a series of weights. Suppose in 8th standard A division, you have weight range from 40 to 60, let's say, and you plot it. You will get something as the mean. Mean is nothing but your total observations upon the number of observations. So what is central tendency is nothing but your observations will generally have a tendency to be around the mean value or the central value. That is, they will be either a little more or little less than the average. So that is nothing but central tendency. So whenever we are taking about central tendency, it is obvious that it should be based on each and every item in the series. It should be capable of statistical analysis and it should have sampling stability. Now what do you mean by sampling stability is that out of, like we had the diagram for, let's go back to the diagram of that sampling frame. Okay. So what does sampling stability mean is that when you have a study population and you pick a sample out of it and you get a central tendency mean value of, let's say, of blood pressure, suppose when we say that it is 80 by 120. Now tomorrow I come with another examiner, I take another 100 people. So again I should have a value of blood pressure that is somewhere around 180 by 120. If I get something else, if I get an extreme value of 60 by 150, diastolic by systolic, that means there is something wrong in my sampling method. So my sampling method should be correct so that my central tendency has sampling stability. That is, from whichever population you take the sample, from whichever study population you take the sample, the central tendency should not vary greatly. I'm still on the last slide only, don't worry. Okay, so whenever you have your central tendency, that is your mean, median, mode, they are generally the middle values or the average values of your findings or your observations, and they have to be based, if you are taking 100 subjects, your central tendency has to include the values of all 100 people. Is it clear? Or do you want 3098? Can you tell me what you want me to explain again, please? Till that 3098 tells me what he or she wants me to explain, we'll just move ahead. Is the video moving ahead for you all or is it still hanging? The video is fine. Can you see the slide according to what I'm saying? Yes, okay, good, fine. So the three most commonly used are mean, median and mode. Just remember for now that whenever you have some very extreme values in your observation, generally we use the median. That is, you arrange your observations in either ascending or descending order and you take the central most value. So that is your median. That is the middle value, that is median. Okay, just remember it like that. The middle value is the median. And always remember, even for MCQs, whenever you have some extreme values, like we were just discussing about weight. So suppose you have most of the people, most of your students are in the range of 40, 50, 60, 55, but somebody is 85 or 100. So that is an extreme value. Whenever you have such extreme values, it is better to avoid mean and go for median. That is the middle value. And then finally you have your mode. Mode is nothing but the most frequent one that you see in your observation. So in your 100 observations, suppose you see that 55 has come the most amount of times, let's say 50 times or 55 times, then that becomes your mode. There might be two values that are occurring with the same frequency, so you can have two modes in the same set of observations. But there is nothing like a negative mode. Okay, so you can have one or more modes, but you cannot have a negative mode. I think this is also a very common MCQ, that do you have something as a negative mode? So the answer is no. Is that fine? Mean, median, mode. Mean is the one that we use commonly. Median when you have extreme values, and mode is frequency. You can have more than one mode, but you cannot have negative mode. Okay, moving on. Now we are going deeper into statistics. That the occurrence of some systematic influence in a study, that is it consistently tends to give an advantage or disadvantage to one or more groups in a study, is known as. Now the answer is bias. The question looks very complicated, but See, now the most simple way to explain bias is, I'll give you an example. Suppose you are doing a study where you want to see that people who are eating more sweets have more amount of dental caries or no. So you take two groups A and B. You see one group is taking more amount of sugar. After say 1 month or 6 months, you go and you check their caries. You find that surprisingly the people who are not taking sugar have more caries. Now why could that be? So suppose now you have got this result. So now you are thinking, oh my god, how did this happen? But see, you have to remember that whenever you are taking diseases like dental caries, they are multifactorial. So it could have so happened that the group B which has not taken sugar but have more caries have very poor oral hygiene, or they already have a lot of caries. So these are the factors that cause bias in your study. Do you understand what is bias? Is they are associated with the disease, but if you don't include them initially only in your sample size and match them, they are going to give you some haywire results. So bias is nothing but a systematic error. Please remember this term, that bias is a systematic error, okay? And bias is eliminated by matching. That if you are checking dental caries in people who are having sugar, you have to match them for other factors like oral hygiene practices, previous dental caries, availability of dentists, etc. Is that clear? Bias, the systematic error eliminated by matching. Okay, we'll move on. Now we are coming finally into statistical tests. The measure of level of agreement between a set of observed and expected value is known as. For now, just know the answer, it is chi-square statistic. I'll just explain in the previous slide about all the statistical tests. Just an overview of the chi-square statistic is that it was given by Carl Pearson. It is a non-parametric test. Non-parametric tests are used when the data is qualitative. I'll just come to the table. Okay. Can everybody hear me now? I'll just explain to you briefly about. Can everybody hear me? I'll just explain to you briefly about the tests of significance. Okay. Now tests of significance are basically into two parts, that is parametric and non-parametric. That is something that is basic and you should know. Now when to apply a parametric test and when to apply a non-parametric test. Okay. Now we just look at parametric. Now whenever we come to a parametric test, the first and foremost thing you should have is a quantitative data. Quantitative data in the form of numbers, that is age or weight, that you can measure numerically, it is continuous. The second one is normal distribution of data. Now whenever you have this quantitative data and you plot it on a graph, you should get a normal curve. What do you understand by a normal curve? It's a bell-shaped curve, wherein you have data that is on both sides of your central tendency and it is equally distributed. So that is a normal curve. The third one is that whenever you have a sample, you should ensure that all the people in those samples, that is your sampling units, have been randomly selected. When you have random selection, it will ensure homogeneousness. Homogeneousness is that they are same in all the variables, that is, it is matching. They are matching for age, they are matching for sex, they are matching for weight, etc. Whatever the relevant variables. So whenever you have a parametric test, these four things are of paramount importance. That is, your data should be quantitative, it should have a normal distribution, that is a bell-shaped curve. All the subjects in your sample, that is your sampling units, should have been selected randomly and they should be homogeneous. Homogeneous is equally distributed around your mean median mode, that is around your mean, the most commonly used central tendency. So that is when you use parametric. Now exactly opposite to that is when you use your non-parametric test. That is when you have qualitative data. Qualitative can be in the form of color. Like suppose color of the eyes. You have to see which is the most common color in the class. Is it blue, brown, grey, black, dark brown? So you will come with something called as frequencies, or you might have percentages that these percent of the class children have black eyes. So this data is not continuous, it's discrete. So whenever you have discrete data like frequency or proportion, that is qualitative data, and you will have to use a non-parametric test. Now there is something called as skewed data. I have put a diagram later on. Skewed data is nothing but that when you have your normal bell-shaped curve, you have the mean in the middle and your values are distributed around plus or minus of the mean. Skewed is nothing but that it is either towards the left, the peak of the curve is towards the left, or the peak of the curve is towards the right. So when you have such kind of data after plotting, you use non-parametric tests. The third one is when your sample selection is not random. When you are using convenient sampling or when you are using quota sampling, just going and taking the subjects who are available, you will have non-random sampling, and hence obviously they may not be homogeneous. So in these cases, you will use your non-parametric tests. Is that clear? Somebody is asking what is covariate. I'll just come to that. Let me finish the explanation. Otherwise, it will just break the continuity. Is that fine? I'll explain covariates along with the questions that are in the end because it is more relevant over there. Okay? Fine. Now, this is the first table. This is showing you, we are talking only about the means. Now, when we want to find out the difference between means, so these 5 tests are the basic tests we are going to use when we want to find out difference between means. Now the most common ones you must be aware are the t-test. Okay. Now the t-test is of 2 types, student t-test and paired t-test. Do you all know where this word student comes from? Where does this word student come from? Anybody knows? Why we say student t-test? What was student or who was student? Yeah, it was the pen name. Very good. It was the pen name of the person who gave the t-test, that is Gossett. Okay. Gossett never used his real name for authorship. He used to use student as his name. So student t-test. So now let's start with basic things. Let's say you have group A and group B. You want to compare the weights of group A and group B, the mean weights of group A and group B. So now 2 groups and mean. So if those 2 groups have normal distribution, they have random selection and are homogeneous, you will use a student t-test. Is that fine? Means of 2 groups, student t-test. Now suppose once you plot the graphs of group A and group B, that is the weight. Now we are just giving an example of weight. Now in this graph plotting you find out that the graph is not normally distributed. It is skewed. Either the peak is towards the right or the left. So you cannot use a parametric test. You will have to use a non-parametric test. And the non-parametric equivalent of a student t-test is a Mann-Whitney U test. Are you all understanding? Whenever the data is skewed in a student t-test, you cannot use a parametric test. You have to use the non-parametric test, that is Mann-Whitney U test. Okay, please keep this table also in front of you. Now here we were talking about group A and group B. Now there will be cases in which you will evaluate group A only before and after. Suppose now you have group A. You are going to evaluate their plaque levels before brushing. You are going to tell them to brush and you are going to assess their plaque level after brushing. So you have the same sample, that is group A. So in such cases, when you have the same sample, just you are taking the before and after results, whatever the intervention will be, it might be brushing, it might be health education, you are going to use a paired t-test. And this is, we are assuming that the data is normal, randomly selected and homogeneous. So you have a paired t-test for before and after means of the same group. Now whenever in the same group you find after plotting that your data is skewed, again you go for a non-parametric test, and the non-parametric equivalent of a paired t-test is a Wilcoxon sign rank test. Is that fine? You have student t-test, non-parametric is Mann-Whitney U-test, paired t-test before and after, the non-parametric is Wilcoxon sign rank test. Then we have something called as a Z-test, that is, it is going to give you the means of two groups, A and B, but on a larger sample, that is more than 30. Whenever you have a sample size of less than 30, this Z-test becomes invalid and you have to use your t-test. 1177 is saying no ma'am. No ma'am is for what? Please tell me what you have to repeat, what I have to repeat also. Okay, so far are we clear with the three tests? Student t-test, Mann-Whitney is the non-parametric, paired t-test, Wilcoxon sign rank is the non-parametric, and Z-test is for sample size more than 30. Okay, but that does not mean that you cannot use a sample size for, you cannot use the t-test for a sample size more than 30. You can use the t-test for a sample size more than 30 also. Now this is when we are talking about group A and group B. Now whenever you have group A, B, C, anything more than 2, those tests cannot be used, or they have to be used continuously. So what is the simpler way is that we use ANOVA. ANOVA is nothing but analysis of variance. It checks the difference in the means in more than 2 groups. Suppose you have group A, group B, group C, group D. You want to check what is the difference in the means. Is it significant or no? So in more than 2 groups, for means we have ANOVA. 117 is saying something for student. Okay, student t-test, the name is derived from the person who gave the student t-test. Student t-test was given by Gossett. But whenever Gossett used to write a book or invent something, he never used his real name. He used a pseudonym that was student. So hence he has named this test student. Is that clear now? 117. Okay. So now again back to means. Okay. So 2 groups. We have student T, paired T and Z test. More than 2 groups. For means we have ANOVA. And similarly the non-parametric variant is Kruskal-Wallis. So more than 3 groups, if you have means and they are not normally distributed or not homogeneous, not randomly selected, you have Kruskal-Wallis. That is the non-parametric equivalent of ANOVA. Now there is something called as repeated measures ANOVA. Now just like we have in the paired t-test that the sample A before and after, sometimes you can take that sample A, you can teach them a brushing method and assess their plaque levels at the interval of 1 week, 2 weeks, 3 weeks, 4 weeks. So what is happening? You are taking the same sample but at different intervals of time. So when you have the same sample at different intervals of time, more than 2 times, you take the repeated measures ANOVA. Okay, is that clear? The same sample multiple times. You are telling group A to brush, you are checking the plaque level after 1 week, 2 weeks, 3 weeks, 4 weeks. So in such cases, we take repeated measures ANOVA. That is, you are repeating the measurement after a particular amount of time. The similar non-parametric equivalent of repeated measures ANOVA is Friedman's test. Please remember all these 4 names. These are very common MCQs, the non-parametric equivalents of the parametric tests. If somebody is asking test for multiple small independent values, what does that mean? Multiple small independent values? Are we talking about means, frequencies, proportions? Can you just type the whole question, or you can email me the whole question also on siley911@yahoo.com. I'll just get back to the question after we've solved the paper for today. I think that's an incomplete question. Okay. Now we come to chi-square test, the one that we were discussing about. So a chi-square test is generally we call it a non-parametric test, but it can be used on parametric data also. It has basically three main uses, that is association between two or more variables. Like suppose you are doing a study on smoking on oral cancer. At the end of the study, you want to see whether smoking is really associated with oral cancer, and that association has some significance. So in such cases, you are going to use a chi-square test. Then it comes to proportion. Now when you have non-parametric data in the form of percentage or frequency, like I want to say that the percentage of knowledge of hepatitis A in students of dental college is so and so, and in students of medical college is so and so. Now if I want to check whether this percentage of difference has some significance, I have to use a chi-square test. And finally we have something called as goodness of fit. It is a more theoretical concept to see whether what we have obtained from our study is really what we already know. Okay, now chi-square statistic, when we have paired qualitative data, like we had paired qualitative data for the paired t-test, like we had here for the paired t-test, that is means before and after, or the repeated measures ANOVA. Suppose you have the same kind of paired data in a qualitative form, instead of the chi-square, you are supposed to use the McNemar's test. Okay, so paired data, qualitative, McNemar's test. Then we have something called as correlation. Now as you know, as age increases, height is supposed to increase. Now how did we come to this conclusion? How do we know that as age increases, height is supposed to increase, or age and height are supposed to be correlated? So all these comes out from statistical studies. And how do you find out the correlation is that we have Pearson's correlation. What is a parametric test to check if the two variables are correlated? That is, as age increases, weight or height is supposed to increase. So they are correlated. As knowledge increases, positive attitude is supposed to increase. So when we want to find out such a relationship, whether there is any positive relationship between age and height, or relationship between knowledge and your positive attitude, we use something called as Pearson's correlation test. This is the same Pearson who has given us the chi-square statistic. Okay, the same man. But now whenever we have qualitative data for correlation, we use Spearman's correlation. Okay, all these names are supposed to be really mugged up and in your brain, because all very common questions. Okay, now that 25 has asked a question, ma'am, to measure correlation between multiple independent values. Okay, now this is the next one that we want to check, that is regression analysis. Now regression analysis is very simple, like we were talking about correlation. If age and height are correlated, age increases, height increases. So similarly in regression analysis, what happens is that we have one independent variable. Now what do you mean by independent variable? Is the main variable in the study that you are supposed to measure. Now suppose I am doing a study on periodontitis in diabetic patients. So diabetic patient or diabetes is my independent variable, and I want to check its effect on periodontitis. Now periodontitis can mean gingivitis, it can mean pocket, it can mean loss of attachment or bone loss. Now I want to check if any degree of change in the independent variable causes some change in the dependent variable. Now if my sugar level is 120 and my periodontal score and CPI score is 1, if my sugar level is increasing to 140, do I have a subsequent change in my periodontal status? Does my pocket depth increase? Does my loss of attachment increase? So this degree of change in the dependent variable with respect to one independent variable is called as regression analysis. When you have quantitative data, you can use linear regression. When you have qualitative data, you are going to use logistic regression. Is that fine? You want to check if the change in degree of independent variable causes a change in degree in the dependent variable. Like blood sugar increases, how much does the periodontal status change? Does this change by 1 chord, 2 chords, 3 chords? Similarly, if you want to find out if your diabetes sugar level is 140, does that mean your periodontal status is going to deteriorate further, like you're going to get a score of 4, or loss of attachment is going to increase to 1, 2, 3. So how do you assess that with increasing sugar levels, you're going to have decreasing periodontal status? So that is what we assess using regression analysis. So similarly, quantitative data you have linear regression analysis, qualitative data you have logistic regression analysis. Is this table clear? Are all those names in your head? 1104 wants me to repeat something. Do you want me to repeat linear analysis? Okay. See, what happens in regression analysis is just that you have one independent variable and you want to check if your independent variable is changing, how much your dependent variable is changing. I'll give you a simple example. Suppose you want to check the level of dental caries in various socio-economic status people. Now you go to the field, you take various socio-economic status like middle, upper, middle, lower, and you check the level of dental caries. Now accordingly you are finding just that as you go down the lower strata, your dental caries is increasing. Okay, that is one correlation that you are getting. That lower the class in the socio-economic status, higher is the dental caries. So that is correlation. But you want to see how much is the increase in dental caries corresponding to the decrease in socio-economic strata. So that equation is regression analysis. That is, in correlation you know that yes, as socio-economic status decreases, dental caries increases. But when you want to know by how much or by what amount of degree is it changing, you go for regression analysis. That if you are going down the socio-economic strata, how much is the change in your dental caries? Is that fine? Chi-square for association is that, like I gave you the example, when you have smoking and lung cancer. Okay. Now you have a set of observations, like you have patients with smoking who have lung cancer, but you will have patients who have not smoked and have lung cancer also, maybe because of occupational air pollution, etc. So how do you say that smoking is the one that is significantly associated with lung cancer? In those cases we use association, that is chi-square test. What it does, it is going to tell you that is smoking significantly related to lung cancer patient, and if the test comes out significant, you can say yes, people who smoke do have a higher odds ratio of developing lung cancer. Is that fine? Okay. Finally we are moving ahead. So now this question where somebody is repeatedly asking me, ma'am, to measure correlation between multiple independent variables. I am not getting the full question. Can you please email the question to me, siley911@yahoo.com. We'll solve it at the end of the class. Okay? Fine. Now this is a straightforward question like we were just discussing, a non-parametric equivalent of analysis of variance. So now whenever you see the question non-parametric equivalent of analysis of variance, so you go back to the table and you have non-parametric equivalent is these two tests, either Kruskal-Wallis or Friedman's test. You have to pick one of the two options. Now obviously Kruskal-Wallis is not here, so it makes it easier for you to pick the Friedman's test. So analysis of variance, which permits analysis of unreplicated randomized block design. Now randomized block design is a type of study design that I will explain in the later half of this lecture. So whenever you have unreplicated randomized block design, please remember you have to apply the Friedman test. Whenever you see non-parametric equivalent of analysis of variance, you know that you have only two options, either Kruskal-Wallis or Friedman's test. Fine. Okay. Now, which is the test procedure that evaluates the possibility that a specific alternative hypothesis is true? Now, I want you to understand that there are basically two types of hypothesis. Okay, null hypothesis and alternate hypothesis. Null, the word itself means nothing or no difference. Okay, so when you suppose you want to start a study and you want, suppose you are taking Colgate toothpaste versus Pepsodent toothpaste and you want to check the level of plaque after you give this toothpaste to your subjects. So now your null hypothesis will say that there will be no difference in the level of plaques in group A and group B. So that is null hypothesis. In opposing to null hypothesis, you have alternate hypothesis, where I am going to say that no, the plaque levels in group A will be lesser or greater than that of group B. So that is what we have as the alternate hypothesis. Null means you are assuming there is no difference between the two, and alternate is that you are already stating that yes, there is going to be a difference between group A and group B. It can either be that group A has less plaque or more plaque. So whenever, okay, now just have a look at this test. Now I think I just skipped one MCQ that is of null hypothesis. I think both of them will be combined and you will get the answer. Just have a look at this diagram of two-tailed test. Now what is happening is that you have your sample, you randomly selected it, it is homogeneous, you plot a graph. Now what we say generally is that we have 95% confidence levels, or whenever your values, that is of group A and group B, fall between this 95% of values, or generally, have you all heard of SB plus or minus 1, standard deviation plus or minus 2, standard deviation plus or minus 3? You all know about that concept. Standard deviation plus or minus 1 covers how much area, standard deviation plus or minus 2 covers how much area, and standard deviation plus or minus 3 covers how much area? Okay, standard deviation plus or minus 1 covers how much area? 68% actually. Standard deviation plus or minus 2 covers how much area? 68.5. Okay, very good. The 5025 has given the right answer. It is 68, somewhere around 98 and 99. Okay, 68, 95 and 99. So generally, standard deviation plus or minus 1 will cover 68% of your curve. Standard deviation plus or minus 2 will cover 95% of your curve, and standard deviation plus or minus 3 covers 99% of your curve. Now whenever we are taking a study, we generally keep 95% as the level of significance or confidence interval, that if something is falling between 95%, it is normal. If it is more than 95%, we mean that there is some difference. So what happens in a two-tailed test or a null hypothesis is you are saying there is no difference. So anything in the 95% is fine. That means it is no difference, it is normal. So your area of rejection is just 95, that is 100 minus 95 is 5, so 5%. But it is 5% on either side of the mean. So it is 2.5 and 2.5%. Okay. So in that percentage they have just given here in the form of 0.025. So it is nothing but standard deviation plus or minus 2 will cover 95% of your curve. So anything in this 95% is considered not significant, and anything that falls in this 95% of your curve will say that the null hypothesis is true. Now 100 minus 95 is 5, but you have 5 on either side of this curve. So it is 2.5 and 2.5. So whenever there is a null hypothesis, you have an area of rejection that is 0.25 on either side. But whenever you have an alternate hypothesis, you are saying something is either greater or lesser than in your groups. Like you are saying no, that group A has less amount of plaque. So if you are saying it has less amount of plaque already, you are already eliminating the plus 3. That is standard deviation plus or minus 3. So you are saying it is less. So it has to be minus 3. Sorry. So it falls only on the left side. So your area of rejection in an alternative